Welcome you all. We're going to have another episode of Genie sessions where I do some live augmented coding and we see how it goes. These sessions are not scripted, not practiced, not rehearsed. This is me following my curiosity, which after all is what I tend to optimize for. I want to find out as much as I can about how this crazy world works, and I use computers to do it. I use programming computers to do it. So today's project, you may have seen me talk about my B+ tree. So I wanted to see if I could write library quality software with the Genie. And the answer is yes. I've implemented, I think I'm up on number 5 or something like that, versions of a B+ tree. And that's faster than what's in the standard library. So that part of it is true. I'm going to look at, make sure that my video is not being truncated here. I don't know. It looks good on. Emmanuel, how you doing? I'm still getting used to this live coding streaming kind of setup, so please do say howdy. It also requires me to split my attention, which is a little bit difficult. I don't know, can you see the whole coding, like my whole face, Emmanuel? I wanted to make sure. Hello, hello. All looks well? Okay, super. Hey, Emmanuel, you're welcome. Glad to be of service sometimes. Okay, I'm going to rearrange my screen. Okay, so the question was, can I write library quality software for complicated data structure? And the answer is yes, with a fair amount of doing. My B+ tree is faster. The B+ tree map is faster than the B tree map in the Rust standard library for everything, all the operations except for delete, which is complicated. But it is faster, and I was able to do it with the Genie, including one version with raw memory, high wire stuff. So we'll see how that goes. So I got wondering, we get these fancy GPUs. Is it possible to have a faster sorted map? So it's the same API, the same external behavior. Is it possible to have a fast version that uses a GPU? So I did a little searching or exploration in Gemini, and it came up and said, yes, you can. But you're likely to need bulk operations. So the API is put, key and a value, get for a key, get a value, delete a key, and the last one, and the reason you use a B+ tree is iterate from key 1 to key 2. Those are the 4 operations that we really care about. But we also want to have bulk insert and bulk retrieval. So put key value, key value, key value, key value, get key, and get all those back. So that's what we're going to do today, is see if we can do a portable version of a GPUSortedMap. Okay, so I'm using, and every time, it's exploration time. So I'm using IntelliJ with Codex I don't know. You should try. Everybody should try everything right now and find out what really matters. But I'm using IntelliJ with Codex, and here I have a basic outline of what it is I'm trying to do. Now, slab allocated sorted array. I don't know what a slab allocated array is, but we're just gonna dive a little bit into implementation, look at the implementation and learn. And this is the key, I think, for getting the most value out of Genies, is not use them to produce code, but use them to create opportunities for learning. And I'll be doing that as I go along. So if you have any questions about what I'm doing or suggestions, or you see me doing something really stupid, please do pop up. I'd appreciate that. Until the Genie, read the README and form a plan. Yeah, there we go. Install Codex. Oh, sure, why not? I told you I hadn't. Unrehearsed, unprepared, not unprepared. I've been programming for 50 years, for fuck's sake. So, this is going to be this is real programming. So I will be cussing as we go along if that bothers you. I'm sure you can use the Genie to write a boulderizer that plan is, I can start with a code-based survey to map. Sure, do that. I don't see the plan, but okay. I mean, I'm looking over here. I don't see it. It didn't share a plan. Now this is something, survey complete, blah, 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 no rest, no existing layout. Yeah. One. So I want to eventually make it, make this implementation accessible from various languages, but I don't want to do that yet. The CAVI version will come last. There we go. We'll see what it thinks about all this. Oh, and I have a GitHub repo for this. I think it's called GPUSortedMap. So if you want to follow along in there, you can. I will be, as much as I can remember, I will be pushing versions as quickly as I can. I have 5 concurrent users. Love this format. Love your work. Thank you, CJ. I appreciate that. We'll see. I'm not dead yet. We'll see if I can keep doing some good stuff. I'm having so much fun, though. Oh, my Lord. I was talking to somebody the other day about, oh, so what project do you have going on? I'm like, project? I have projects. I have many projects going on at the same time. So, all right. We have a get ignore. We have a cargo, so fine. Dependencies byte muck. What does that do? ByteMuck provides safe-ish zero copy casting between plain data and byte slices. Then serialize them with bytes of, so they can be written directly into GPU buffers without manual byte padding. Okay, that seems reasonable. Mostly, I hate dependencies because I'm doing exploratory work. If you've seen the stuff I've written and published in various formats around 3x, explore, expand, extract, in that exploratory phase, you don't want any dependencies because you want to go as fast as possible. And then as you expand, you still don't want many dependencies unless they're absolutely critical, and an extract unless it's absolutely rock solid and you don't care. You don't need to resolve this conflict. Failed to run cargo. Get cargo to run. We'll see what it needs to do. I should read this more thoroughly. Package G sorted map, but she does not have these features. Failed to select a version for WGPU. So WGPU is WGPU. I think that this is, well, it's got to wait until we're done with the next one. I think we need to, I think WGPU is the cross-platform GPU interface. So we'll, I didn't want to just use CUDA directly. Which reminds me, I started learning about CUDA when NVIDIA was a gaming company a million bajillion years ago. So run command, cargo build, allow for session. Bad user interface. It was waiting for me and didn't tell me it was waiting for me. Cargo needs network access to fetch crates.io dependencies for the build. Yeah, fine. So we could probably make something back to WGPU. This is a stream that's perfect for what I call the boredom sensitive. Other people call ADHD. I do not have a deficit of attention. I just get bored really easily. So we'll be jumping between different topics as we go along. And if you ask any questions over here for me, I'm gonna pull that into the thread too. So here we go. Rename crate to snake case. Okay, here's updated the build step setup. So WGPU compiles without the non-existent util feature. Initialize the meta buffer via mapped creation in source librs. Okay, so let's go look at the Rust code that it's implemented. Here we're kind of squeezed. I have an enormous monitor, and it's a Dell. They are not yet a sponsor, but it's the Dell 49-inch 32:9 aspect ratio monitor, and I love it. But I can't show that to you because we're streaming here. By the way, if you ever have any comments about the production of this, you can't see this, or the colors are bad, or you'd like me to grow my hair back or something, please let me know. Okay, if you want, I can rename it. And what is WGPU? And then we'll do the rename. Here we go. Cross-platform Rust graphics compute API. Net maps to native backend bends. Fine. So we're going to cost ourselves some performance in order to have portability, and then after a while, if we get to it, we'll squeeze the last few bits out. Okay. So KV. So what Rust? We have a KV entry, and we're going to restrict ourselves to 32-bit integers. Just for now, and then we'll put that on the to-do later. Remind me later to generalize to key type, generalize key type and value type. But later. Okay, slab meta, length, capacity, and padding. Okay, fine. GPU sorted map. Okay, so this is the root of what we want to create, a GPU sorted map. Just tell me when you're ready to revisit it. Fine. Hello, Hébert. I'm totally butchering the pronunciation, and I apologize, but not that much. Okay, so A GPU sorted map has a device queue. I don't know what that's for yet. We'll find. Slab buffer, input buffer, meta buffer, capacity and length. Okay, so I don't know what all those are. We're going to find out. Boy, I wish I could use a smaller font, but also my eyes aren't so good. So we have a new, so update length. Okay, so write and run a test that just creates a GPU sort GPY. Here we go. If you've never done this before, I strongly recommend streaming like this because it's high anxiety. But I'm learning something. I hope you're learning something too. Okay, so here we go. We just create one and run its allow cargo test. Yeah, we're going to run cargo test a lot of times. So if this passes, or when this passes, we're going to take a snapshot. Push. Simple unit test. Pass. Only warning is crate name, not snake case. Okay. Yeah, rename the package. This is an interesting. Then commit and push. That's an interesting question. Like the structural change, renaming the package, we just got it. We just wrote a test and got it to pass. So the dogmatic interpretation of separating behavior and structure changes from Tidy First. If you haven't read Tidy First, read Tidy First. What was I saying? Oh, the dogmatic says we would separate those into separate commits, and I'd let them find that. Okay, I need YOLO mode here. We're gonna leave it like this. Rename crate and add GPU map. See, if you have to put and in a commit message, then you probably screwed up already. Now we'll say this. Okay, push to origin main. Yes, do it. Okay, so what we have here just creates one, but we don't have get, put, delete, get all, put all, delete all. All right. 10 concurrent user. We're up to 10. Howdy. Glad that you don't have anything better to do on a Friday than watch me talk about programming and have some fun. Here's the secret. This is fun for me. Oh my goodness, I love doing this stuff. See, this is a user interface bug. It was waiting for me like this and didn't tell me. There needs to be one place that I go for it to tell me, all right, I'm waiting for you now, boss. As long as it's gonna, it should actually do it, be good at it. When I say bazinga, commit and push. Bazinga! Now let's see if it actually worked. I haven't gotten any chat messages for a second. There, now I actually see this. What does that cargo lock file do? Oh, here's another one of these. What does the cargo.lock file do? Always ask the Genie. Rule number 1, 2, and 3, when you're doing augmented development, just always ask the Genie. Records the exact version of every dependency, binaries, or when you want deterministic CI and builds. Yeah, we probably want that. Okay, so the next thing, implement a test for get and then for put and then get. Then make the code work for the test. There we go. Well, I'll give it a little bit of rope. Now, oftentimes I'm more, what do I want to say, more directed, more specific, more controlling with the Genie than that. I tell it kind of specifically, I'm designing bulk put and bulk get. No, I didn't ask you to do that. I'm going to have it take it out. Planning CPU side bulk get put. No, I don't want CPU side. Maybe I do though. Maybe I do. Maybe I'll just, well, let's see what it implemented. So we have bulk put. Wow. Kent, how do you proactively manage the agent context window to achieve the best results possible? Do you look at the number of tokens used? You know, so far, CJ, do you use a, wow, you're gonna see some boredom sensitivity in action here. Do I use a master prompt? I'm trying without it. This is an optimization process. I want to see what the baseline looks like. And I haven't used Codex in like 3 weeks, so maybe it's magically gotten better. Sometimes it does. How do you manage the context? I would love to be able to track the number of tokens and get a sense of it. I feel at this point, maybe 1,000 hours into augmented coding, I have a sense of when things are starting to go wonky and it's time to break stuff into pieces. And I may be wrong about that. So there's a tool for somebody to write a little tool that helps me manage my context and says, all right, well, yeah, I did that thing that you asked for, but we stretched above 30% of the context window, or 40%, whatever the number is, when the Genie starts going badonkos. I think I just implemented CPU backed bulk put, bulk get. So a put then get test works while keeping GPU buffers updated for future kernels. Okay, so that's fair enough. As an interim, so the next thing I'm going to do is tell it to go ahead and make the bulk get and put real. Capacity overflow, put then get, unit test. Okay, so where's the test? We have 3 entries. We bulk put them. We bulk get them and make sure. Okay, so we still need a single key value API. Do we want to do this first? Yeah, I'm a little miffed. But anyway, we still test for and then implement that next. But first, Bazinga! There we go. Personally, whenever I see Claude Code say, you are absolutely right, that's the moment I get really scared. Sure, remember, it's trying to keep your attention. That's what it does. Add for session. librs wasn't already in there? Ooh. All right, whatever. But the Bazinga worked, so that part's good. Yeah, I mean, this whole glazing thing, I don't like it. I understand why they would do it, but there you go. Wow, we're 25 minutes in. Time is going zippity doo-dah for me here. And I'm being very American English here, and I apologize for that. But when I'm coding, like if I was talking to you directly and I could see your reactions, I might be different. But I'm 80%, 70% focused on the programming part of this task, and we'll see what else goes from there. Next up, want that as put and get key option U32. Exactly. So you have to butter it up a little bit too. I don't know about Codex, but I know with Claude, it would only be a single prompt to get it to write a subagent, just an MD file that tells it to make sure it warns you every time context hits greater than 40%. I'm going to have to put my glasses on to actually read the name. Oh, I'm not even going to try because I'm sure to mess up. It would be worse. Is it worse? There we go. We should have a poll. Is it worse to try and mess up the name, or is it worse to just say, I'm not confident I could do that? If you want this committed, say Bazinga. I know that. I just told you that. Okay, so now let's have a look. I just assumed it was going to be good. Map, put, map, get. Now see, I would split this into two tests. Okay, so I'm just going to tell it to split this into two tests. Yeah, this is the kind of thing where do we have a test? There we go. Get the missing key, GPUSortedMap, pollster block on. That seems like a weird API, but okay, fine. Anybody have any suggestions? Okay, so now we can put in delete. Now its suggestion for delete was that it doesn't readjust. It just puts in a tombstone when you delete. So the key is still there. The value is some tombstone. So we got two dimensions. One is we could put the bulk get, bulk put on the GPU. That's what I'm really interested in. Like implementing delete, we know how to do that. So move, what's it called? Bulk get and put, re-implement bulk get put on the GPU. That's what we care about. We want to see how this works. Like the end state I'm going for, I may go for like an hour or so before my head explodes here. Before I implement it, and you should bulk put, do the merge on the GPU, or is it acceptable to keep the merge on the CPU and only upload the merge slab to the GPU for now? Ugh. What are the trade-offs? given that we want high performance later. Yeah, right now we don't care what the performance difference of the two is. Right now we care about what's going to set us up, what's going to help us learn as much as possible between now and when things get really messy. CPU, much simpler, deterministic, easy to test, good for correctness. CPU becomes a bottleneck. Slabs are not scalable, later cost, we'll need to replace it. Let's do the GPU merge. Okay. Oh, hybrid short term. No. GPU merge. Let's try GPU merge. If it proves too hard, roll back. There we go. So this is the kind of thing that I would do. Which reminds me, trying to get the Genie to code like I code, I think is the wrong frame for how we want to do this. It's better than it coding worse than I am, but I think it excludes the possibility that the Genie might be able to come up with a much better version of programming than we're currently experiencing. I have ideas on that project, one of my million projects, but we'll see. We're up to 18 concurrent users. I think that is an all-time record for the Genie sessions. Thank you all so much. We're a half an hour in, maybe a half an hour to go. We'll see how this works. Uh-oh. Codex, we have given Codex a poser. Apparently, it's having a little bit of difficulty with this. Oh, and we are using here GPT 5.2 Codex medium, high, extra high. We'll stick with this and see how far it gets us. One of the nice things about coding with the Genie is you get plenty of time to talk. When I'm pair programming with somebody or whatever, we need a name for this that is not menage a trois, because people would get the wrong ideas. Two programmers, two human breathing programmers, and a Genie. What do we call that thing? It's like 2.5 men or something. Palamondo. Thank you very much for asking. I forget. In the radio, they used to call this a reset. They'd come back and say, "We're here with so-and-so and so what we're doing is, these are the Genie sessions. So this is me and all of you together coding with the Genie. The problem we're solving is a map with sorted keys, which is a problem that I've spent hundreds of hours on, augmented coding. Yes, we're using strict TDD, but that's because, wow, that's because that's all I can think of to do. Okay, we're stopping. What's going on? Wait. What's going on? You were, you seemed blocked. This whole anthropomorphism thing, that really kind of has me too. I don't like it, but also you do it all the time. Yeah, I should have a timer that goes off, and every 5 minutes I say, "Welcome back. As a reminder, we're implementing a sorted map on a GPU." Okay. I'm laying out a plan to implement GPU accelerated bulk put by sorting input and merging it with the slab buffer via compute shaders. That sounds awesome. I would have no idea how to do this. I'd have to learn so many things before I could even get started. So this is I know the external behavior I want to create. I have some vague vision of how to get there. And I have no idea about the details. So this is like absolutely dead center bullseye Genie territory. I'll start with the minimal GPU bitonic sort on the layout, on the input, and a merge kernel combining sorted inputs and slab using temporary buffers and pipeline layouts with fallback if too complex. There we go. That is what we wanted it to do. I'm just hella surprised that it's taking this long. If you see my eyes go outside, it's because just outside of my office there are a bajillion birds flying around, and so I see ravens and buzzards and hawks and a host of little tiny birds going, and with boredom sensitivity, woof, woof, woof. So it's not that I'm not paying attention. I am surprised that this is going so slowly. So we may need to break this up. We'll see. GPU map error. Put. Yeah, this is how I'd implement put. Single key put. Get. Host slab, binary search by key. Huh. Okay, interesting. Bulk get. So it seems like it's actually implementing stuff here. But then it's hanging. Why is it hanging? Okay, this one. This is an ugly piece of work. We definitely need to work on this. I's, J's, lens. Ugh. Yeah. So this is all the complexities getting pumped into bulk put. Ooh, all right. So it claims to be done. Worked for 187 seconds here. Yeah, that's a fair amount of stuff. Reviewing buffer usage and sizing. Cargo test failed. Good. Updating pipeline descriptor. Cargo test done. All right, we definitely have some work to do here. Merge kernel and reduce CPU involvement. Okay, so what are we doing? If you want this committed and pushed, I know. Why is it telling me that? I told you that. Bazinga is our favorite. All right, so let's read. Claims it's finished. No block. I implemented a GPU-backed path for bulk put and bulk get. Compute shader, binary search, and tests are green. What changed? Bulk get now dispatches a compute shader and reads back results from the GPU. Good. That's kind of what I wanted. Bulk put uploads sorted deduped input. We didn't tell it about I think puts. Okay, so I'm going to add a to do item. Should we allow duplicate keys input? Because that in a bulk put. That I'm not sure about, but I don't want to think about that right now. So much of programming is thinking about stuff and choosing what not to think about. It's not so much thinking about stuff well as choosing what not to think about so that you can reserve your brain power for the stuff that matters most at the moment. Okay. Yeah, I was doing a lot of reasoning, Sumita. That was a little crazy. Unexpected for me. Okay, kernel's inline and the associated pipelines bind groups. Okay, so we need to know what a bind group is. Merge kernel is single-threaded. Correctness first. We can parallelize this later. Capacity check is conservative. May still reject even if the true merged length would fit. Yeah, I get it. Test run. Okay. Commit and Bazinga. We don't, that's Bazinga. There we go. I wish that I could just say get commits are fine, but there we go. Concurrent users went down a little bit. That's fine. To do for bulk put duplicate handling. Okay. I'd allow duplicates and define deterministic behavior. Typically last write wins within the batch. And batch wins over existing slab. I don't know, fine, whatever. Keeps the API forgiving. I don't, anyway. Let's caller skip pre-deduping. If you want strict behavior instead, okay, fine, whatever. To do, we're going to do that later. All right, so what are we doing? So write the first little performance test. Compare a B tree map with GPU sorted map for 110 ... 1, let's call it is that a million key random keys. And so mostly I think we care about fetching behavior. Mentioned performance as a priority goal. Is somebody, Palamondo, that's what I'm adding right now. Thank you very much. So I'm not scared of getting the behavior right. Yes, we need to do it, and we're going to have to go in and define some validation because I don't understand the implementation right yet, but that's fine. But yeah, let's establish how close, how far away are we? Run it, save the results in a directory where each commit gets a performance run so we can track changes over time. So where I expect, here's what I expect. I'm going to call my shot here. We expect the bulk get to be slower if there are a few keys and faster if there's lots of keys. That's kind of, if we get there, we will have made good progress on this. And by the way, if we run out of time here, I got about 15 minutes left to go. If we run out of time here, I'll come back to this again sometime next week. Not to worry if you're concerned. So, more questions? I'm happy to get the questions, especially when the Genie. Oh, I should have gotten my water. Always be hydrating. Let's see what it says. Once again, I can't see that. Cargo needs network access, blah, 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 for dependencies and to run the performance binary. Fine, please do that. thanks you all for showing up. It's even though I live kind of out in the boonies, I get to program with people, even though the interface to what you're doing is quite small. New performance binary. Okay, summarize the perf results. I don't want to go look at some CSV file. Come on, pup. GPUMap is faster. How much faster? GPU get is flat and low. Okay, so that's interesting. GPU get is already much faster than BTreeMap get at large sizes, but GPU put is still slower across the board. Okay, bazinga, that. I'm surprised that get would already be faster? Question mark? What do you think? Pardon the nose. Things are starting to bloom here. I bet you it's waiting, yeah. Lots of little commits. That's the way it goes. And we're pushing. Remember, you can go to my GitHub, GPUSortedMap, and you'll see it. Okay, so what are the options next? Parallelize GPU merge. GPU side filter, CPU pre-processing. Optimize bulk get. That sounds interesting too. These all sound interesting. It really wants to write this CABI layer. Pick a number and I'll proceed. I don't know. You pick a number. Viewers, you pick a number. I'm inclined. Let's see. What did it say about performance? Get is already flat and low. Put is slower. So let's just fix put, I think. What's the ratio of get put ops we're testing? I don't even know how to properly. What's the ratio? So this is ask the Genie. Always ask the Genie, and then we may want to check. Thanks, Palamondo. It's 1-to-1 for each size n. The harness does n inserts followed by n lookups, which might be wildly inaccurate for a particular use. Do number 1. We'll see if it remembers what number 1 is. Parallelize GPU merge with a real merge path kernel. Yeah, so what we want is to end up with something where we're using the GPU as much as possible. I'd also really like to do a remote agent version on a machine with NVIDIA chips, just to see how that is different. Do you recommend deletes? Oh, DSLs when writing acceptance tests. Test from different layers without changing the test. You know, I tend to write all of my tests in the programming language because I don't like switching languages like that. Oh, Oh, Palomondo, about that ratio of get and put ops. We could make the performance tester programmable that way. Anyway, Groot. DSLs, I just write tests at the performance in the same language. That was one of the novel decisions in S-Unit/JUnit was everybody had a DSL for testing. And I just decided if I can not introduce another language, that eliminates one, it eliminates so much complexity, and two, it makes testing approachable for programmers. Remember, back then, programmers didn't write tests. So if I could figure out Ergo test, all right. I wish I could see the results of that. Okay, I'm not blocked. He's careful to reassure me. Okay, back. What was I was talking about? Oh, so back then, programmers didn't write tests. So our primary goal, my primary goal with a testing tool was getting programmers to actually use it, because zero, effectively rounding to zero programmers were writing automated tests. So that's why I do that. Hello, Kent. Hello, Sergey. An overall question, probably for a pause or end of stream. I want to encourage people in the company to use the Genie and share knowledge to learn together. Any tips or thoughts on that? Yes, that is an outstanding idea. It's the only way that lasting change comes to communities, is find a few people, start using the thing, and then talk about it. So, internal DSLs using the language. Groot, that's exactly how I view the APIs that I'm building. I think that that's a DSL, and I want to express both my tests and my implementation in those terms. Not blocked. All right, relax. Fixed, replaced the single-threaded GPU merge with a merge path style parallel kernel. Each thread, we want to go look at this implementation. Probably, we'll do, okay, so we're going to stop here and do some reading. Replace each thread, merges a chunk of the output range. Total output length is slab length, blah, blah, blah. Tiebreaker favors input when keys are equal. Keeps, but duplicates can accumulate. Still flagged by the to do. Okay. Yes. Rerun the performance. Always run the perf test first when I say bazinga. Bazinga! I can't spell. There we go. This way we'll be able to track how did the performance of this change over time. Now this is, there's a lot of implementation here of stuff I don't understand. Like this WGPU thing, I don't know anything about that API. We're using a bunch of it. I wish that we were using less of it before I went and went on with what I was doing. All right, parallelized GPU merge kernel. Here's where I'm going to really wish I had more screen to go and look at it. If you want a quick comparison between a new perf run, say the word. The word. We'll see if it gets the joke. Ah, it knew. Codex, you're so clever. Put improved at larger sizes. 38% faster. I'm surprised. Okay, no, I'm not surprised that put went faster. GPU put got slower, size 100. We don't care about small numbers. GPU get stayed about the same. That should be. B tree numbers are roughly stable. Good. Parallel merge helps GPU put for medium large batches, which is the goal. Okay. So now let's go have a look at this whole, wow. So we got a lot of lines of code here. We're maybe not ready to, wow. There is some stuff here. Okay. So let's just take a pass through and see what we can see. This is all the same as before. Result entry, pad, slab meta, keys meta, input meta, merge meta. Oh, okay. Yeah, this padding is apparently very important. So good, we know that. We have a device, a queue. Wow. This is a lot. Okay. So I'm trying to understand a bunch of stuff at once. So I'm not going to bother about stopping at every single thing. I kind of want to know what's the high level organization first. So I'm going to take a quick pass through. How are you building confidence in the correctness of the Genie solution? Correctness like behavior correctness because of the tests. Performance correctness because of the tests. You specified all the expectations as examples in the test suite before. We need way more tests than this for sure. If you look at that B+ tree, it's got a lot more tests than this. Get bind group layout. What is a bind group? Okay, so I am going to ask some questions. What is a bind group? I could ask Codex for an overall tutorial in WGPU, the parts of it that we're using it. Specific slots declared in a shader. Okay. Shape of the binding, then create a bind group with actual buffers and bind it before it dispatches. So the shader sees the inputs, outputs. Okay, so this seems like we're declaring a bunch of resources on the GPU side. Fine. And it's got some schema, a layout of stuff. Can't use yeah, that's what I'm going to be doing, but I don't know what questions to ask yet. So I just read top to bottom for the moment. But yeah, we could use, okay. Groot, thank you very much. Teach me about the parts of WGPU that we are using. Now we're going to run over time, my time. I'm going to take about, I'm going to stop this at an hour just because my throat's getting dry. But quick map, okay. Discovers DPUs, adapter bit picks one, device creates GPU resources, queue submits work and writes to buffer. So queue is like we're talking to the GPU. This is the phone. We pick up the phone and say, hey, GPU, do this, do this, do this, do that. The buffers are memory blocks with usage flags. Okay? Shader module, WGSL code compiled for GPU execution. The kernels, which we haven't looked at yet. This will be interesting when we look at it yet. And bind group describes and binds the actual buffers to shader bindings. Still don't, it's still vague for me, but I understand some of it. Compute pipeline pairs a shader entry point with a pipeline layout so it can be dispatched. There's lots of layers of indirection here. But Okay, cool. Command encoder records commands. We set pipeline plus blind group and call dispatch work groups. You submit. Read back mapping, copies GPU output into a CPU visible buffer so we can read the results. If you want, I can walk through a single call end to end. Ooh, that sounds great. Yes, please. Plah. Ask it to use metaphors. Oh, yeah. We'll try that. We'll try that experiment. Outputs. Allocate results buffer. Build a tiny keys meta buffer holding the length so the shader knows how many keys. Okay, tell me this story like a fairy tale. I don't know. I've had haikus. I've asked it to write a rap for me, all kind of stuff. So let's see. In the land of WGPU, there lived a quiet kingdom called the Slab, guarded by a wise keeper named Betty. I love this. Oh, the queen, scroll of keys. Okay. Save that. And bazinga. There we go. Now, you'll be able to read the whole thing. And I'm going to read the whole thing because that sounds hilarious. And then we'll be done for today. And I hope you have a fantastic weekend. I'm planning on doing that. Actually, I'm planning on going to play poker in a little bit. So that will be fun. Palamondo, thank you so much. I'm glad you're finding my work useful. Yeah, definitely. If you don't know about Tidy First, you are not going to get the stuff I'm talking about. I guarantee that. So, Groot, great. You are definitely onto something. That we've got this. We have this resource that places enormous demands on us. The Genie requires a lot of effort for a programmer who's not used to it. But it's also a magnificent resource. So we might feel that we're overwhelmed, but anytime you're overwhelmed, you've got this, I don't want to call it a friend, we have this resource. And we can call on that resource to help us deal with that resource. And that's the loop I'm trying to create. So add bulk, get, fairy tale, and perforin. Perfect, fantastic. Thank you so much. And I will talk to you again soon, I hope. Bye-bye.